So my coefficient of determination tells me what percentage of RV, the response variable, is dependent on my EV. So for example, if I have a scatter plot, between, let's say, the number of cars in a particular city versus uh, the air quality index or the amount of pollution, let's say I have this kind of a scatter plot. Now, if I ask you that what is the association? So you will say that this will be a strong positive linear association. And if I ask you, okay, give me the value of R. So either you will guess it or you will find it on your calculator. And let's say the R value that you've got is positive 0.9. Now this R value tells me it measures the strength of the scatter plot. But it does not tell me, hear me out again, it does not tell me that what percentage of the AQI is dependent on the number of cars. So what percentage of RV, the AQI, is dependent on the number of cars, the EV. Now, in order to find that, what I do is I square this value, the R square. So let's quickly square that value, positive 0.9 square. If you square that in your calculator, you'll get 0.81. Times it by 100%, you will get 81%. And that is what my answer is, that in this scenario, 81% of the cases, my RV, which is my AQI, is dependent on my EV, which is the number of cars. 81%. Now, the question that you can ask me is, what about the remaining percent? I mean, 100 take away 81 is 19%. So what about this remaining 19%? Where is that gone? It simply means that this 19% of the scenarios, AQI might not be connected to the number of cars. So that could be the other factors that are influencing my AQI and not the cars. So is this clear? So my coefficient of determination eventually helps me to determine what percentage of RV, the response variable, is dependent on the EV. Is that clear, everyone? Yes?
Yep.